We are looking at another questions on initial value problems. Okay, we have solved t times second differential plus 2 times fourth differential plus ty equal to 0. And we have some conditions there, some boundaries, some conditions here that y of 0 is 1, y prime of 0 is 1. So let's see how we can get the solution to this using Laplace. So step 1, as we said, if you want to solve Laplace equation, the first step is to take what? Take Laplace of the given equation. Ty equal to 0. Okay, and let's get the Laplace transform for those okay. So first of all, we need to note that I've said that when you have Laplace of t of f of t, okay, yeah, I want to use 1 in this case now. So this will be equal to minus d dx. That will be first differential of Laplace of f of t. Okay, so and we have, if it's t square, you have f of t. If you have a Laplace of t square times f of t, that will now become minus 1 square, then second differential, okay, then Laplace of what? Laplace of f of t. So that's the, well, we have to note those two, this equation. Okay, so this will now become minus for the t, then d dx of what? Of Laplace of what? Laplace of second differential of second differential as a function of t. There, so that one is done. We'll write the expression later, then plus 2 to bracket Laplace of what? Y prime of differential. Okay, then here also, here there is t here also, so that will be minus, that will give us minus d dx of what? Laplace of y. D dx of Laplace of y equal to 0. So that's what we have now. Then we can now write the Laplace transform for those equations. So that will be minus d dx of, this will become x squared, s squared Laplace of y of t minus x y of 0, then minus y prime of 0. That's the first differential. Then plus 2 times Laplace of first differential, which will go to x Laplace of y minus y of 0. Okay, then this one will just be equal to minus Laplace prime y of t equal to 0. So I'm going to copy that there. So then let's look at the initial value condition we have. This one, y of 0 is 1. This one is 1 here. Y prime also is also, this one is also 1. Let's just put 1 on top there. So, and that means we're now having minus d dx into brackets s squared Laplace of y of t, okay, minus x, this one, minus x, okay, then minus 1, okay, then plus 2 times this one, that's 2x Laplace of y of t, okay, then y of 0 is this one is 1, this is 1, so that's 2 times 1, that's minus 2, then minus what? Laplace prime y of t equal to 0. So we can now start differentiating. Now we can differentiate this one. If we differentiate this one, that's a product rule, and that will be minus into brackets s squared. Take down the constant, differentiate the Laplace, differentiate this Laplace, then plus 2x, and now differentiate your s squared and take Laplace constant y of t. Okay, then this will be what? Minus 1 here, and this will be 0. Okay, minus that one is gone, so you can close this one. So plus 2x Laplace of y of t. Okay, minus 2, minus 2, then minus Laplace prime y of t equal to 0. So we can allow this minus to go in the bracket, which is minus s squared Laplace prime y of t minus 2x Laplace y of t, and then plus 1, and then plus 2x Laplace y of t. Okay, then minus 2 minus Laplace prime y of t equal to 0. Okay, so we can factorize now. We have the Laplace prime can be factorized minus s squared minus 1 Laplace prime y of t. You can do that. Now factorize that. Laplace prime y of t. Then this one minus 2x Laplace plus 2x Laplace cancel out. Okay, so we now have now 1 is there. We have 1 here, 1 minus 2, which is what? Minus 1. Then move it to the other side, equal to what? Equal to 1. Okay, so Laplace prime y of t is equal to 1 over what? 1 over minus x squared minus 1. Then you can factorize this minus, and that will be equal to what? Minus 1 over what? S squared plus 1. Factorize this minus. Then you have, if you do that, you have minus outside. Then you have s squared plus 1. Differentiation here on the Laplace. This prime here, then we'll take the integral on both sides. If you take the integral on both sides, you have to just remain Laplace of y of t equal to what? Integral of what? Minus 1 over s squared plus 1. And that will be equal to what? Laplace y of t equal to the integral of this with respect to x. Okay, integral of this will be equal to arctan x, and don't forget the minus there. So that's that. Then you can put any constant we like, whether b or c, plus b or c. The choice is ours. So this is what we have now. Okay, this is what we have. Okay, then the target now is we are looking for y, not Laplace. Okay, so what we are going to do before we get the solution is to find this b, and then we need to note that that this is a fact, that limit of a Laplace as x tends to infinity is 0. Okay, so we're going to take the limit of this Laplace. So limit as x tends to infinity of the Laplace be equal to minus limit as x tends to infinity minus arctan x plus b. Do that. Okay, so if you put your x is infinity, arctan infinity, that's pi over 2. So that will be minus pi over 2 from here. This one is just a constant. So don't forget to equate this one to 0. Okay, so that's a plus b equal to 0. So b is what? B is pi over 2. So once you get your b now, then you can come back here and now have Laplace of y of t equal to what? Minus arctan x plus pi over 2. So we've not finished yet. We just get the Laplace now. Then the next thing to do now is to I just want to emphasize expatiate this one more. When you are here, okay, you need to get the b, and for you to get the b, the best thing is just to take the limit of this as x tends to infinity. Okay, and the fact is that limit of Laplace, okay, as x tends to infinity is 0. It's just a known fact. Okay, use that and get your b. Laplace of y of t equal to minus arctan minus arctan x plus pi over 2. So let's take the inverse of both sides. So if you take inverse now, you have y of t equal to what? Inverse of this minus arctan x plus pi over 2. Okay? So what we're going to do now, we don't have inverse for this arctan. Okay? We're going to introduce differentiation. We're going to do some little adjustment here. Okay? And that adjustment will call for this inverse of d dx of the function minus arctan x plus pi over 2. Okay, and the moment you introduce the first differential, it will now bring in minus what? Minus t. Yeah, it will bring in minus t there. Okay, the moment you introduce, because there is no way we don't have inverse for this arctan. So the the solution is just differentiate this and then find the inverse. And the moment you introduce your differential, minus t will come in. Okay, I'm going to expatiate that. I'm going to expatiate that one more. I'm going to expatiate that more. Okay, and this will now give us inverse of this will be equal to arctan x is what? Arctan x. That's derivative of this of arctan x is minus 1 over s squared plus 1 plus 1. That's derivative of this, and derivative of pi over 2 is just a constant. Just a constant. Just a constant. That's equal to minus t y of t. And then the inverse of this minus can go outside, which is minus outside inverse of 1 over s squared plus 1. Okay, and that will be 1 over, this is arc sine, this is sine t, minus sine t, and that's ty. Okay, so the minus can cancel out, and y is equal to what? Sine t over what? Over t. So that's the solution. So y of t is this. So y of t is that solution for that. Okay, and don't forget that the inverse of 1 over s squared plus 1 will give you this. Okay, so that's that solution on that. So let me quickly digress and Laplace of tn f of t will give you this. That's just the end of that question. That's just solution to this. I just want to make a little digression. Okay, so I just want to make a little digression. Laplace of this will give you minus this. Yep. Minus 1 to the power n, then Laplace of what? F of t. Laplace of this will give us minus 1 into bracket n, okay, d dx of Laplace of what? F of t. Okay, so that's that. So if you're now having Laplace of t f of t, in this case now, this will become minus 1. This is this, but this. If your t is 1, if your n is 1, you have this. So, and that will be equal to minus 1 d dx of what? Of Laplace of what? F of t. Okay, the inverse of both sides. Okay, then you have just t f of t here equal to what? Minus inverse of what? Of d dx of Laplace of what? F of what? F of t. Okay, and then this minus can go to multiply both sides by minus, then you have minus t f of t equal to what? Inverse of what? d dx of Laplace f of t. Okay, so and that's what we have used there. And you can see now minus t f of t inverse ddx of that Laplace. So that's that on that question.